In this video, I will explain how to find the coordinates of stationary points using differentiation. Suppose we're given a graph like this one shown here. It's obvious that we've got a maximum point here and then a minimum point over here. So if I was to draw the tangent at any point, I would be seeing different gradients all around. However, if I was to draw the tangent at the particular maximum and minimum points, I would see that these would be simply horizontal straight lines, and they would satisfy that their gradient is 0. Now, we have already seen that to find the gradient of any curve, we simply find an expression for dy dx. So the idea is that if we find dy dx and we set it equal to 0, we will be able to find the position of maximum or minimum points. So the first thing to do is find dy dx, set it equal to 0, that will give me the x coordinate, and then substitute this value of x into the expression for y to get the full coordinates. So let's look at a few examples. The instruction is to find the coordinates of the turning point or points on the following curves. So for the first one, dy dx is simply 6 minus 4x. Remember, we get the power down and we deduct 1 from the power. I will set dy dx to be 0, which simply means that 6 minus 4x is 0. So 6 is 4x, and we get that 3 over 2 is the value of x. We still need to find the value of y to complete the coordinates. So when x is 3 over 2, y is 7 plus 6 times 3 over 2 minus 2 times 3 over 2 squared, which gives an answer of 23 over 2. And therefore, there is only one stationary point, and this has coordinates 3 over 2, 23 over 2. In the second example, it's a cubic. Dy dx will be 3x squared minus 6x minus 9. I will set it equal to 0. I observe that I've got a quadratic which I can divide throughout by 3. So I get x squared minus 2x minus 3 is 0. This factorizes into x minus 3, x plus 1. So either x minus 3 is 0 or x plus 1 is 0, which means that there are two stationary points at x is 3 and x is negative 1. I substitute the value of x is 3 into the expression for y, and I get that y is negative 12. And similarly for x is negative 1, I get that y is 20. And therefore there are two turning points, the 3 minus 12 and the point negative 1, 20. The third example, y is x to the 3 over 2 minus 3x plus 1. We get the power down, so it's going to be 3 over 2x to the power of a half minus 3. I will set it equal to 0, so 3 over 2x to the half is equal to 3. So 3x to the half is 6, which simply means that x to the half is 2. To get rid of the power of a half, I square both sides, and I get that x is 2 squared, which is 4. And when x is 4, y turns out to be negative 3. So there is one stationary or turning point at 4, negative 3. Our final example is somewhat different. The instruction says, show that the curve with equation y is 2x cubed plus 5x plus 9 has no turning points. So I will start by finding an expression for dy dx. So dy dx in this case will be 6x squared plus 5. If it was to have a turning point, there should be at least a value of x for which this is 0. However, we start by observing that x squared is greater than or equal to 0 for all real values of x, which means that if I multiply this by 6, I still have that 6x squared is greater than or equal to 0. And if I add 5, I get 6x squared plus 5 is greater than or equal to 5. Hence, 6x squared plus 5 is greater than 0 for all x. And since dy dx is not equal to 0, the curve has no turning points. So in other words, there is no value of x that will make dy dx is 0, and therefore we have no turning or stationary points. In case you are wondering what this curve looks like, we can look at its graph. There it is. It's a graph that keeps going upwards. We say that it's an increasing function. There is no maximum, there is no minimum. I keep going upwards from left to right, so there are no turning points. Thanks for watching. If you found this video useful, please like it and subscribe to our channel. You can also leave a comment below to tell us what you think.